Hey, welcome to episode 4 of Gardening Coyote. So, today I just want to address the issue of hybridization and I guess the corollary issue of heirloom tomatoes. Um, People say that grocery store tomatoes are hybrid, and if you grow a seed from them, that you're not going to get the same tomato, which I don't really understand why you'd want to in the first place, since grocery store tomatoes generally suck. But that is generally true. You can buy overpriced heirloom tomatoes at grocery stores, but for the most part, when you go and you buy something for a non-exorbitant price at a grocery store, it's going to be hybridized. And what that means is that the plant's been crossed, and to in order to get certain traits, there's this thing called hybrid vigor, which basically says that hybridized tomato plants grow stronger and frequently have less health diseases, even though that's not a specific gene in hybrids unless it's bred into it. But the end result is that uh, generally grocery store tomatoes are what they call an F1 hybrid, which means that their parents were different varieties of tomato. Now, when you have an F1 hybrid, um, all the tomato plants in that generation are going to have largely the same traits in terms of fruit size and appearance and stuff like that, which is why grocery store tomatoes, you look at the big bin, and all tomatoes look just about the same because they're the F1. When you get into F2, assuming that there's no further cross pollination, you're going to start to see the genes segregate, and at the F2 generation, you will see a great variety of fruit sizes and shapes and whatever, depending on the diversity of their parents and the genetics there. If both parents are, just, I don't know, basic Roma tomatoes, then they might start to look kind of the same. But you're definitely gonna start to see variations, and that's I've got an F2 generation growing outside right now, and that'll be a great way to kind of like show how the genes segregate. Genes will continue to segregate up through generally about F6. At F6, at the sixth generation after hybridization, assuming that there's no more accidental cross pollination or deliberate cross pollination, um, the varieties you have will generally be stable, and they'll grow the same year after year. So from one F1 plant, assuming that you grew hundreds and hundreds of seeds at each generation, by F6 you could have hundreds and hundreds of varieties of tomatoes, all with like slightly subtle differences. And at that point, they would be stable. And if you saved a seed from them, from F6 to F7, generally those plants will grow true to type. And you'll see throughout the generations that you'll see less variation throughout the generations because the genes are segregating. I am not exactly a botanist. I don't have a science degree, even though I probably should have got one. But there's definitely places that explain gene segregation and desegregation in tomatoes much better than I can. But anyway, just from a practical gardener perspective, I'm going to show you some differences at the F2 generation, and basically the parents I had. One was, I believe it was a commercial Roma type tomato that for whatever reason I collected and grew. Not the greatest tomato. And then the other parent was a black beefsteak type tomato of Russian origin. So an amazing tomato. It was actually an accidental cross, but we're seeing some pretty cool developments at F2. Um, I'm going to so far I have one plant that's showing the recessive trait of being a beefsteak, and I'm going to select from that plant mostly, focus my efforts there. I might pick one or two of the other ones and just see where that line goes, but I'm probably going to select for the beefsteak since it's a recessive, and B, who doesn't like beefsteak tomatoes? So let's get outside and look at tomatoes. So maybe a little bit hard to see here, but there's actually three plants. You can kind of tell by the support stakes I have put in for them. Two of them are in this kind of storage container looking thing. also hard to see, and one of them is planted directly in the ground. Now all three of these plants come from seeds of the same tomato from last year, and that tomato was the F1 hybrid. So this is the F2 generation, and at F2 you start to see variations as the genes start to segregate. So this plant, you can see it has kind of that cherry tomato truss formation, the way the fruits form along that kind of straight line with alternating, I guess, little vines that come out. And if you look at the fruits, they have like this kind of like little nipple end at the bottom, and you know, they're starting to get a little bit shiny, the skin. And when a green tomato's skin starts to get a little bit shiny, it's kind of signaling that that tomato is getting close to as big as it's gonna get. It might get a little bit bigger, but not a whole lot. So this is gonna be kind of like almost like a pointed cherry tomato, or I guess some people call it a saladette. But that's one tomato, and kind of interesting. At the bottom of that leaf truss, you can see that it's actually growing more leaves, which sometimes happens. So that's one tomato. Over here next door, again, this is basically from this is from a seed from the same tomato as the last one. You have a bigger tomato. This one, you can see it's got some green. It's got some green shoulders. It does not have that universal ripening gene, which is kind of the bane of all grocery store tomatoes. But it's different. It's got a different shape. It's got almost kind of like a little recessed blossom end, and it's going to be significantly larger. Like back there, you can see that these guys, they're not quite a beefsteak, but they're, you know, they're a good sized tomato. And then again, next to it, yet another plant. Oh shit. Well, I guess I broke that off. So another small variation. The color is a little bit different than the one I just showed you, and the shape. I would say that the shape is a little bit longer and less boxy. But again, so these are three different tomato plants, and you're seeing some pretty significant variations. But there's more dramatic variations over there. Okay, so here's two more plants that again are F2 plants from all coming from the same tomato, and here we see some very marked variations. This one kind of ripens in a yellowish green. It's not ripe, but I mean, as it's ripening during the process, it's kind of a more yellowish green, different color. Again, the shape is more elongated, but it's a lot larger than those cherry-looking tomatoes that we had over on the other plant. And then this is kind of like my crown jewel of the F2 generation. We're looking at a pretty good sized beefsteak type tomato. I've got pretty big hands, so like that's a good sized tomato. That's definitely like something you can slice up and put on a bagel or make some bruschetta or something like that. But it has beefsteak is typically a recessive trait. So even though this is only F2 and it's not going to be stable until it's F6, I'll probably save from this because it has that recessive trait. So all these other tomatoes, it'll probably be less likely that it will express that recessive trait. So this, I save a bunch of seeds from this tomato, and next year I might still end up with some cherries on some of the plants, but I have a better chance of retaining that beefsteak fruit formation up through F6, and at which point it should be stable and I should be able to get beefsteaks time after time.